one of the things that we did in our last lab, or last lecture rather, is that we were doing what's called balancing equations. We have a chemical equation here, and it involves your reactants, so things that are reacting, and also your products. But what we have to do is we have to make sure that this reaction is correct by balancing. And if you remember, we can't be changing the formula, the chemical formula, by adding subscripts. For example, we can't change H2O into H2O2 because that changes it into hydrogen peroxide, which is a completely different formula, completely different chemical. So what we have to do in order to balance is we have to use what are called the coefficients. And these are the numbers that are found in front of the chemical formula. So we also had another handout where you guys were counting the atoms, and that's how you actually have to balance equations. You have to do so by counting atoms. That's going to be the first step in the balancing process. And for your lab handouts, one of the handouts is going to require you to do this mathematically, but then there's also going to be an option on the second handout for you guys to do it mentally as well. So we'll go over both methods so you can see both of them, but we're going to be primarily focusing on the mathematical version. So when counting atoms, if you remember, we have two sides of an equation. We need to make both sides equal by using those coefficients. We're going to make both sides equal by using coefficients. So we're going to have a chemical equation down below here, and we're going to be balancing it by counting the atoms. So if you can leave some spaces available for those coefficients, because that's what's going to be going in front of these chemical formulas. So we're going to be combining nitrogen, N2, and also hydrogen, which is H2, and then this is going to produce or yield a compound called ammonia, which is NH3. So it doesn't matter which one that we start with. We can either start with trying to balance the nitrogens, or we can start by balancing the hydrogens. Let's start with the nitrogens because that's the first thing that comes. So I'd like to write an N on this side of the arrow and also an N on this side of the arrow for the nitrogen. We also are going to be counting the hydrogens excuse me, on this side, and also the hydrogens on the other side. Remember, this arrow is an indication that it's going to be producing the products over here. So we're looking at the nitrogen and the hydrogen on the left-hand side, the nitrogen and the hydrogen on the right-hand side. Well, how many nitrogens do I have? For this, we need to take a look at the subscript. So this means that I'm going to have 2 nitrogens over here. Okay, let's go to the other side. How many nitrogens do I have over here? Take a look at the subscript, and I have only 1 nitrogen. So I have 2 here and I have 1. Remember, if you don't have a subscript, it means that you truly have 1. It's like in mathematics. If you have 2x plus x, you have 3x. The x implies that you have 1x. So I need to make these balanced. So how do I make these balanced? I make these balanced. What's going to be my common factor between 1 and 2? It's going to be 2. So I need to multiply my nitrogen, my 1, by 2 in order to get 2. Now I have 2 nitrogens on each side. How do I show that? This is mathematically like using the distributive method. I'm going to put the 2 in the front right here. Now I have 2 times 1 nitrogen, and that's going to give me 2. However, it also is going to alter the number of hydrogens. How many hydrogens do I now have? I have 2 molecules of NH3, and they each have 3. So 2 times 3, here I have the 2 times 3 is going to be equal to 6. Well, I need to have 6 hydrogens on the other side. So let's go back to the other side. And how many hydrogens do I have? I actually have 2 hydrogens. So it's going to be 2. What am I going to have to multiply the 2 in order to get to 6? I have to multiply the hydrogens by 3. And 2 times 3 equals 6. So what do I have to do? I have to multiply or put a coefficient in here, and the coefficient is going to be the 3. So that's how to balance this mathematically by counting the atoms. Again, we started with the 2 nitrogens over here, and we only had 1 on the other side, but we need to have 2. So we're going to have to multiply it by 2 by adding a coefficient. But what that does is it also multiplies the 2 times the 3, which gives me 6. Since I have 6, I'm going to be taking my 2 times the 3 to also equal 6. We're going to be doing a few more of these, but if it's confusing, it could be confusing for many. Other people can do this very, very easily. So if you're having any questions, please email me and we can Zoom and do some more examples. But hopefully by the end of the lecture, you'll get the hang of it. Now I want to do this mentally. So that's showing all of the work, but there's also a mental way of doing this. And this is for individuals that feel that they have a really good grasp of this. So we're going to write the original chemical equation, which is starting off with nitrogen and hydrogen, producing an unknown number of NH3s. Well, let's actually approach it from a different way. Let's say we didn't start with the nitrogen as we did last time. Let's say that we started off with the hydrogen. Here I have 2 on this side. Here I have 3 on this side. What's going to be the reconciling number between 2 and 3? What's going to be the lowest common multiple of 2 and 3? Hopefully you're saying 6. So we're taking a look at the 2 here. We're taking a look at the 3 here. And the common multiple is 6. Just like, what's the common multiple between 2 and 1? It's 2, so I have to multiply this by 2. So what am I going to have to do to get 6 hydrogens? Well, currently I have 3. I'm going to have to multiply this by what to get to 6? 3 times 2 will give me 6. And 2 times what will give me 6? And it's going to be 3. So now we should just double check. So now we have 3 times 2 is 6 hydrogens, 2 times 3 is 6 hydrogens, 2 times 1 is 2 nitrogens, 2 times, which is a 1 right here, 2 times 1 gives me 2. So therefore, this is going to be balanced. That's a balanced reaction. So let's go through the steps. We're going to be doing more counting. Okay, so here's our third example. And these are going to get a little bit more complex. We have PCl5 plus H2O produces or yields H3PO4 plus HCl. So the first step in this, we're going to go through the counting method, is to list all the elements. So that's our first step. We want to list all of the elements on each side. Okay, so I have a P. Let's put the P here. I have a Cl, which is next. Going down, I also have an H, and I also have an O. So on the other side of the equation, we're also going to have P's, Cl's, H's, and O's. So first step is to list all the elements. Then we're going to be counting using the subscripts. Count using the subscripts. How many P's do I have on the left? I have 1. How many Cl's? I have 5. How many H's? I have 2. How many oxygens? I have 1. Do this right now for the other side, showing how many P's, how many Cl's, how many H's, and how many O's that you have. And pause and then come back. Okay, hopefully you've finished this and you'll see that how many P's do I have? The subscript for the P is 1. That looks pretty balanced. How many chlorines do I have? I have 1. How many H's? This is a little bit tricky because I actually have 2 compounds with H's. So I have 3 here, and then I have 1 here. That means I have 4 H's total. How many O's do I have? I also have 4. So what I need to do is I need to go down and balance them one after the other. Let's start with the P. There's 1 P here, there's 1 P here. At this point in time, nothing is needed for that. But if you look at the chlorines, I have 5 here, and I have 1 here. So what's going to be the common multiple between 1 and 5? It's going to be 5. So I have to multiply this by a 5. Now, when multiplying it by a 5, that means I have to use that as a coefficient right here. So let's see what happens here. Now this gives me 5 Cl's, but uh-oh, look what happens to my H's. I now have 5 H's here, and I have 3 H's over here. 5 times 1 gives me 5. 3 times 1 gives me 3. 3 plus 5 is 8. So what I'm going to do is I'm going to, instead of multiplying this, I didn't multiply this by 2 to get to 8. I actually, just by making it 5 HCl's, it made the H's into an 8. So I'm going to cross that off and put the 8 there. So my P's are balanced, my Cl's are balanced. Now my H's are not balanced. What do I have to have in order to have, what's the common multiple between 2 and 8? The lowest common multiple is going to be 8. So what do I need to multiply the 2 by to get to 8? 2 times 4 is going to be equal to 8. This 4 is going to be the coefficient over here. So remember we multiplied the other side by 5, okay? That gave us 5 Cl's, but it also gave us 5 H's. 5 times 1, 5 times 1. When we are taking the coefficient of the 4 here, this is going to give us 4 times 2 for that, but it's also going to do this. It's going to give us 4 times the oxygen, 4 times 1. So what happens is we multiply the oxygen also by 4 because we have that as a coefficient. It's the same coefficient right there. So 4 times 2 gives me the 8. 4 times 1 gives me 4. And if you notice, now they're going to be balanced because I have the same numbers of atoms on both sides of the equation.